Hello everyone, welcome and thank you for joining us for this webinar brought to you by Kentik and Capacity on the state of routing security, progress, challenges and measurement. My name's Ben, I'm from Capacity Media and I'll be hosting this webinar, and I'd like to introduce the man of the hour, Doug Madory, Director of Internet Analysis at Kentik. Before I pass over to Doug, who will discuss BGP routing security and an in-depth look at the current state of routing security, both the progress made and work yet to be done, I'd like to just go through a couple of the ground rules before we kick off. So Doug will take it from here after this, but you'll have 50 minutes for an in-depth Q&A at the end. But please keep those questions coming in throughout the webinar, and we'll answer all those at the end. In the unlikely event that you have any technical difficulties at all, please just refresh your window. It should bring you straight back, and it should correct it. If not, drop us a line. We'll be able to sort you. With that, I'll pass you over to the man, the myth, the legend. That is Doug. Over to you, sir.
Thanks, Ben. Let's see. We get the slides up, or we get the slides.
There we go. Thanks, Tim.
Terrific. Thanks. All right. So my name is Doug Madory. I'm the Director of Internet Analysis at Kentik, and this is a discussion of the state of routing security, something that I spent a lot of time analyzing and writing about. So one of the things I've done in the last couple of years is looking at ROV adoption statistics. So if you've seen my talks in the last couple of weeks or a couple of years, a little bit of this maybe repeats, but I'll kind of quickly go through this to get us into some of the new material. But we have to kind of talk about RPI ROV, so route origin validation. And for those who are new to the concept, this is a mechanism in the routing PKI that has two steps for it to work. We have to have address owners create ROAs, route origin authorizations, typically through the RIRs that define the correct origins for the address space, as well as the max prefix length, which we'll talk about. That's step one. The ROAs have to, we have to have that information, that ground truth to compare against. And then step two is that we have to have networks, ASs, out on the internet that reject invalid routes. Invalid being a route that appears and either has the origin in the AS path does not match the origin in the ROA, or max prefix length issue as well. So we need both steps to work in order to identify what are the bad routes that could cause disruption and reject them, suppressing them from propagation, and hopefully avoiding any of the disruption that can occur. So that's the basic concept here. And just a quick aside about some of my take on how I've been looking at this problem. So ROV, all this routing security stuff is about protecting traffic. So why not look at it from the perspective of traffic? I'm a BGP analyst, and when I came to Kentik back in 2020, one thing that was super cool was that we have a very large amount of NetFlow data to work with. That's something I'd never had before to understand what's the impact on internet traffic. So Kentik, for those who aren't familiar with, we are primarily known as a NetFlow analytics company. We have hundreds of customers around the world that send us live feeds of NetFlow from their routers. We process this and analyze it in a number of ways, and but we have by virtue of that, we have a slice of the traffic. We don't have all knowledge, but we have a slice of the traffic passing through the internet at any given time in our systems. And we have about half of those customers have opted in to allow that data to be used in the aggregate analysis, some of the stuff that we'll see here where we don't know, what particular customer it came from, but it helps guide our understanding of RPI adoption. I will mention that that this the data set is subject to biases, as nearly every data set is. We are a U.S. company. We have a lot of U.S. customers. That does it could contribute to a skew. Companies that use our services are typically a little more sophisticated, a little bit more resourced. That too can have a big difference. We have a lot of good relationships with network service providers, content providers, the companies that make up the ecosystem of the internet world, as well as enterprises, which are just some other large network, large company that has a big footprint on the internet. So having said all that, last point I'll make here is that we started integrating RPI into the NetFlow analytics at the request of Job Snyders, who's a frequent collaborator of mine, where at the time in the early phases of RPI adoption, a concern that was getting aired was that people didn't want to reject invalid routes, thinking that maybe they're going to lose traffic that's important, that their customers are going to be upset about. And so the best way to answer that question is just to throw it in NetFlow and say, what would you lose if you, and it turned out that it became inconsequential. I feel like that's a settled matter in general. I don't hear that that concern so much anymore. Partly it was due to tools like the Kentik, and there was other NetFlow tools that tried to answer this question. If you were to start rejecting invalids, exactly what would you lose? Often it's not anything that you care about, so you should go ahead and reject invalids. What's neat is I don't know that use case gets used that much anymore, but I'm able to use this then to say, all right, give me the global view of traffic going to routes with ROAS, and we'll see some of that here. And just to let you know, like the way the system works is that as each NetFlow record is ingested, at the time of its ingestion, the router that provides it, we annotate each record with a lot of attributes, and one of them is what would both the source and destination IPs, if they, from the perspective of the router generating the NetFlow record, would those routes have been valid or invalid, or what have you. That's where the data comes from. All right, so with all that out of the way, let me move on to the next slide here. So now we're back to ROA progress, ROA creation progress. So this is the step one of that step 1, step 2 slide from the beginning of the presentation. And as you may know or may not, back in May last year, we crossed this milestone of that more than 50% of V4 routes have ROAS in the global routing table. This is using the NIST RPI monitor tool as a measure. A graph is from their website. It's increased a bit since then, although it may be slowing. V6 achieved it the previous fall. That says fall 2022, but it should be fall 2023. I think V6 was a little ahead of the game, partly because it doesn't have some of the legacy address base that exists in V4. In fact, there's kind of no legacy in V6, being the newer addressing scheme. And so then that's just purely from BGP counting routes, which I think it's easy to understand that mechanism, but I think it's also kind of gives short shrift to the progress that we're making. And so my take back in 2022, when I started getting into this, was saying, well, what could we look at this from a perspective, from a traffic perspective, because it turned out that we were actually farther ahead than we thought. At that time, we were at like just 1/3 of BGP routes had ROAS, and but the big insight was that we're seeing over half of the traffic in bits per second going to routes with ROAS, meaning that we've actually made more progress than we thought. There's more traffic that's eligible for the protection that ROV would provide. That was due to RPI deployments at a bunch of content providers and eyeball networks, entities that push a lot more traffic than their route counts would otherwise suggest. And so that trend has continued. Some recent numbers back in October 2024, there hasn't changed that much since then. But we at that point, now we're at over half the routes have ROAS, and we're approaching three-quarters of the traffic in bits per second going to routes with ROAS. Like I said, it hasn't. I've run this recently, and I think we're still hovering around 74%. So I had wondered aloud many times, like, at one point, are we going to reach some sort of plateau where all the easy gains have been made, and now we're into the tougher stuff, tougher gains. So those are, as I mentioned, we've got legacy address space, like the U.S. Department of Defense announces a lot of address space and creates no ROAS. I'm not sure where the status is with their relationship with Aaron, but they don't have to go through Aaron. They own their this is the North American RIR, and it's a complicating factor for them to create ROAs by not having being this legacy address base, um, and there's other examples of that around the internet. So I think those are tougher nuts to crack that we'll have to address if we're going to keep making progress here. But I would say 74%, about 3/4 of the traffic. We've made a lot of progress. I think this is a system that is now achieved escape velocity here and is creating benefit for the entire internet. So then on the flip side here, on that second side, the step 2, the rejecting of invalids, I decided to take a look at this from just a route propagation standpoint. There's been a number of efforts out there to try to identify remotely. I think it's a very challenging thing to do reliably, to figure out what ASs are rejecting invalids and which ones are not. There's a lot of factors that go into that. So I kind of punted on that question and just said, all right, well, how about what's the net effect of a route being invalid versus valid? And so then I started looking at this back in 2022. This graph on the left, maybe you've seen this, where we were looking at just how much. We look at the global routing table for v4 and v6 and route views data set dump for one day. How far do these routes propagate? And so the x-axis is number of BGP sources in route views. So this is basically a measure of propagation going across the x-axis. And so you have this peak that appears very similarly in both v4 and v6, both not found and invalid, where those are the routes that are globally routed. And then at the bottom in green, we have RPI invalid routes. As I mentioned, there's at any given time, there's a lot of persistently invalid routes. And we can use those to measure just how far though they propagate. But I had kind of been encountering this just in my day-to-day BGP analysis work, that a route that's invalid just doesn't go very far around the internet. And this is trying to capture that at a internet-wide scale. This distribution gets pushed over to the left, and I would argue that it's been pushed even farther over to the left since this analysis was first performed. And so that's where we're looking at the graph on the right, where I was trying to come up with ways to measure this through time of like that population of invalid routes. How far are they propagating? Again, you want them to propagate less, and you want that propagation to be decreasing through time as more networks are rejecting invalids. So the graph on the right, there's a couple different ways. This is one way. They all kind of show the same thing. Here we're looking at a bunch of route beacons. So RIPE announces a variety of beacons, not just this RPI stuff, but they have beacons that turn on and off at different intervals. It's a lot of stuff for testing and research, but they also have these routes that are intentionally valid and intentionally invalid, just to measure or to measure a variety of things. In this case, I'm going to use it to measure propagation. How far do those routes propagate in the route views data set? And then just to corroborate that, Job Snyder's my frequent collaborator. He operates his own beacons for the same purpose. So, we throw them in here. They all kind of exhibit a similar behavior where, the blue line along the top and all three graphs kind of augering up as the data set, the route views data set slowly grows over time. And then the lines on the bottom are augering down as invalid routes are propagating less through time as a result of more ASs rejecting invalids. The biggest event there was last year. We had Zio start rejecting invalids around April of 2024. And so that leaves us just with one transit-free network. Telecom Italia is the only major tier 1 that is not rejecting invalids, and I'm very hopeful they'll do that soon, because then that would create just a universal cap there at the top of the internet, that when we have origination leaks or other types of BGP mishaps, they really can't go very far and they can't disrupt a lot of traffic. And we've made a lot of progress on that front thus far. But it's nice to have a live demo here we'll call it a live demo. This was an incident that took place in North Korea just a couple of weeks ago, where last year our live demo was the Orange España outage. If you recall, that incident was where a hacker got into the right BenCC account of Orange España and wanted to do some vandalism. So they created a bunch of ROAs that intentionally were wrong. So they had the wrong origin AS and rendered a lot of the routes of Orange España invalid, causing this national outage. The outage could only happen because you have a lot of networks rejecting invalids, is the way I looked at it, the glass half full from the outage. And here we have another case here, another something that hopefully we can draw some lessons learned from North Korea here. So officially they just have one AS. It's been the case like that for the last 15 something years. It announces 4/24s. This is an incredibly small network to represent an entire country. KP is the 2-letter designation for North Korea. They published one ROA with a maximum prefix length of /22. Okay, so that's going to invalidate those 4/24s because 24 is going to be longer than that maximum length. Of course, the routes become invalid, propagation drops off dramatically, they suffer an outage. I'd be fascinated to learn if anybody in this audience was actually affected by that. I think it's a bit more of an academic development. About 16 hours later, they then published a correction where they published ROAs with new ROAs with /24s, but maybe you can avoid this mistake, learn from North Korea's error, and not have this happen to you. So that gave them at the end of it a 100% ROA coverage, which is pretty good. There's actually quite a few countries in Asia that have very high ROA coverage. Their neighbors to the south, South Korea, KR, is only at 0.2%. They are one of the lowest. So maybe this could be something that prods them into action of greater adoption of ROV. This is a little visualization I made. This is one of the routes coming out of ROA. The text may be a little small here, but this is the one. So North Korea, up until, I guess, let's see, about 8 years ago, only went through China. They have one route that goes through Russia, because they've got a small border with Russia. And so this is the one route that gets announced through Trans Telecom. And what we're looking at on the left is the period of this collapse, this routing collapse as the route becomes invalidated. This graph, the colors are from the perspective of all the BGP sources around the internet going to, in this case, Trans Telecom, also known as TTK. What was the penultimate network? So how do they get to TTK to get to North Korea? And you see this kind of collapsing. And at that time, it was 174 Cogent, 3491 PCW, 6461 Zio. They all drop out when this becomes invalid. 16 hours later, thanks to SpongeBob, we have a restoration, and then it kind of comes back. It's a little interesting to see this kind of staggering of how the different upstreams. They have a different set of upstreams on the way back, which is interesting. I mean, this is upstreams of TTK. I'm not sure what that signifies, but it's important to recognize that when a route changes state from invalid to valid and back again, the ROAs take a certain amount of time to propagate through the RPI system when you publish something new. On top of that, different networks update their RPI information at some sort of frequency. It's not instantaneous. So some of that shows up here. We have kind of providers kind of coming, accepting these routes at different times, because that's when their system refreshed its data and now would allow this route to propagate. But it's kind of interesting to see this kind of fluid dynamic pattern in routing. It's something I personally like about BGP. So lessons learned, definitely review ROAs before you're going to publish them, especially the max length. That seems to be a common area of misunderstanding. So, and I've mentioned that at any given time there's a whole bunch of persistently invalid routes that are in circulation. If you're to go and look at what caused them to be invalid, a lot of them, I think the majority case is mismatches in this max length thing. And I can only my theory is that probably when the row was created, it matched the routing and it was probably fine. Then later the routing was changed and somebody didn't go back um, and fix the ROA, and somehow the network is not aware, or not, maybe they have a covering prefix or something. Something is, otherwise you'd be so offline that you'd have to remediate this. But there's networks that just they are persistently invalid for a long period of time. That max length is an optional field that's not well understood. In fact, there was a best common practice published a couple of years ago that recommended leaving it out just for this this issue of people making mistakes. And if you leave it off, you're only going to match on the origin, the AS origin, and not the max prefix length. So something to consider. And as I mentioned, once this issue was resolved, North Korea had 100% ROA coverage. South Korea is only at 0.2%. And if you were to dig into that 0.2%, you would see that this is actually not even South Korean providers. These are it's like Amazon and Google. It's cloud providers that have operations in South Korea. That's where the ROAs are. There is almost no native ROA creation for South Korea. And I believe it has to do with the process there in that country, where KRNIC controls the process. And I'm hopeful they're working on a solution there, because they be great for them to catch up in that regard. All right, so let's shift gears here. So ROV, RPKI ROV is a more modern, newer technology here. Now we're going to talk about something that's older, but is still super important. This is IRR-based route filtering using AS sets. So just a point of clarification here before we get started, that we're talking about AS sets and not AS sets. So BGP, unfortunately, is one of those. In BGP vernacular, there are multiple, we'll call them overloaded terms. The same thing means two different things in very subtle different contexts. So so this is the IRR AS set route object. This is a record in the IRR database, defines a group of ASNs used to try to simplify routing policies. This is not the BGP AS set construct, which is presently slated for deprecation. I don't know which one's more widely known. Maybe the IRR one is widely known, but I think a lot of people also know the BGP AS set thing. So I think this is kind of required clarification here in this conversation. But if you encounter the BGP AS set in an announcement, you'll see like the little curly braces in the AS path. And so what this is was an attempt to do was to consolidate a bunch of different BGP messages, where a whole bunch of prefixes get announced in a single message from a bunch of different origins, and all the origins are just contained, kind of tossed into this bucket in this in these curly braces. It breaks any kind of association between what origin is originating what prefix, so it breaks any kind of ROV or a variety of other routing security mechanisms. So it's something that is seen less and less, although it is still out there. But anyway, so we're talking about the IRR AS set. That's this conversation. And we'll start with a BGP leak. So there was actually a more recent one with Voxility, the DDoS mitigation provider, that I wrote up a couple weeks ago, but got the slides here for this one from March 2024. It's essentially the same situation. In this case, you've got Russian mobile operator MTS mistakenly propagating about 30,000 routes picked up from HKIX in Hong Kong through its transit providers, Lumen and Aurelion. This is a little tweet from QRater. I do a lot of collaboration with those guys. They do a lot of BGP analysis and are some smart dudes that are friends of mine. So in this, I mentioned that we have this NetFlow data. Again, as a BGP analyst, it's super cool to be able to pivot and look at, like, hey, what was the amount of traffic that got impacted by this incident? So this is an example of that, where I'll see a routing leak, and then pull all of our data and say, like, well, what do we see going down this particular path? And I can query all of our NetFlow records by a AS path subsequence that matches what we saw in that's an indicator for the route leak and get a sense for how much traffic got misdirected or dropped. Usually there's more traffic that gets dropped than misdirected, but the misdirected stuff's interesting. So then in this case, you've got like Hong Kong, Indonesia, Australia being the top 3 countries that were impacted from a traffic perspective from our customer base. And here's a little visualization of one of the routes that got sucked into this leak. So this is a Netflix route. The route is on this graphic here. It's normally only seen by about, I don't know, maybe 20% of our BGP sources. During this bulge, there's this big blob here in the middle where HKIX becomes the global upstream for this route, and what's happening is that this is what we call a regional route. Maybe there's other terms for this, but this is some content providers will just announce a more specific, just to a particular geographic region, and there'll be usually a covering prefix, but if just for that region, then it's meant to do some sort of traffic engineering. But the problem is that because 80% of the internet doesn't have an equivalent route, then when a leak occurs, that leak just fills in the vacuum and there's nothing to contend with. So even if the AS path is super long or there's other kinds of issues with the route, it'll be adopted. And because it's a more specific, it also will usually disrupt some traffic. So I don't know what the impact on Netflix was here, but this is just one of those 30,000 routes that got misdirected. But hey, mistakes happen, and since this is an adjacency leak or a path leak, depending on what term you like to use, ROV isn't going to help. The origin is intact. It's the same origin, so they're going to be RPI valid from that perspective. But we've got AS sets, right, to enable transit providers to programmatically build appropriate allow lists to prevent the propagation of leaked routes, right? Well, it turns out this doesn't always work, and there's a couple of reasons why. So in this particular case, as was the case with Voxility and a bunch of other leaks that have happened in recent weeks, you have if you look at the provider involved and look at their AS set, you can see that, and go to like bgb.tools is a great resource for exploring AS sets. This expands to 43,823 ASNs. That's a lot, given that there's only about 83,000 in the global routing table, plus or minus. And if you were to apply this AS set to a routing interface, you would have a crazy list of networks that supposedly are allowed to be transited by this Russian mobile operator, including some examples here. We have the U.S. Department of Defense, Rural Telephone Company in Kansas, United States, American Express credit card company, AWS, the National Government of Kenya. It's all over the map what is included in this AS set, and that is supposedly allowed to be transited by MTS. It shouldn't be. That doesn't make a lot of sense. In fact, this expands to over 1 million v4 prefixes. So one popular tool for building BGP filter lists based on IRR data is BGP Q4. The GitHub link is on the slide here, and if we looked at this AS MTU and this Junos configuration, to pick one, we would come up with a configuration that's 1.3 million lines long that you would be applying into your router's running configuration. We can use the AS option to try to aggregate that, reduce the number of lines to only 250,000, but it's still, or 1/3 but it's still a lot. And most of it shouldn't be there. That's stuff that MTS shouldn't be allowed to transit. The routes contained in this AS set, if you were to go through and count up the unique IP addresses, it's about 1.8 billion unique v4 addresses out of a total of about 3 billion that are currently in the routing table. This is excessive, and it's not going to prevent a leak. And this AS MTU is not alone, nor is it anywhere near the worst. So I reached out to Ben Carre-Cox, the creator and founder of BGB.tools, and he ran the numbers. I could do this too, but I looked at his tool. I was like, I bet you already have this data on hand, and sure enough, he had this. So He was kind enough to run this for me and come up with some of the biggest AS sets that are out there, and there's a lot that are excessive. This top 10 here, everybody's about 102,000 ASs. There's only 83,000 in global routing, so we have like another 20,000 that are unrouted ASs that are included in all these AS sets. There's almost 2,200 AS sets in circulation that are over 1,000 ASNs. So again, there's what good can these possibly do? In fact, not only do they make it so, or here, I'm getting ahead of myself here. Yeah, so what's the problem? Our only hope to reduce the harm from these BGP mishaps is automation. We can't do this manually. And this IR data enables automated generation of allow lists on session filters. And so we kind of need this. We need something along these lines. But these excessively large AS sets defeats the whole purpose of the allow list, or they're kind of just a permit any. But not only that, it comes at a cost that this breaks a lot of automation. I had conversations with a couple of cloud providers, a couple of tier 1 networks that they have to build custom workarounds to their IRR intake based on these AS sets that they can't they either can't consume these, or they have to do something to clean them up or something. But there's a computational expense. If you were to apply this to one of these AS sets to a router, there's a storage and computational expense. These these AS sets get refreshed, maybe multiple times a day. Every time you're pulling this data over, that's all going to be thrown away, or is actually defeating the whole purpose or the mechanism of IRR route filtering. So this is an issue that I don't know. I'm trying to bring some attention to, and I think some of it has to do with the fact that we have AS sets are allowed to be nested, and so this nesting kind of gets out of control to the point where I think the people adopting these AS sets don't know what's even in them, and the things to do here are check yourself if your network. Do you have an AS set? Are you including, what do you have included in it? If you're including other AS sets, what do those include? Do you expand this out and the routes look legitimate? Be careful what you're including, and try not to pollute this space. This is kind of a tragedy of the commons scenario. Only include the things you want to transit, and what concerns me is the nesting of AS sets, and I think that this is creating a lot of loss of visibility and traction. To understand what is getting included, and back to this leak, this MTS leak. I don't know if Lumen either they adopted they were using this excessive AS set, or it was too excessive and they couldn't use it. Either way, it's not helping prevent the disruption that occurred during that leak. All right, so I'll take a quick aside here just to talk about one kind of non-routed BGP security issue, and that has to do with proxy services. And this has been around for a while, and it's going to be with us for a while. This is a pretty hairy issue, but this has, we bring up the issue of routing security. This needs to be mentioned, that this is a recent case here where we've got an actor on the internet getting address space and registering it as if it was from AT&T mobile service. And so what proxy services are is they are trying to sell access to networks that can't be blocked or won't be blocked, those being mobile network operators and like residential broadband, things that content providers need to accept connections, otherwise they're going to lose their whole customer base. So proxy services operate in a few different ways. One is they actually embed into devices that are on those services and try to sell access to them. And then there's also this kind of thing where they don't go through the trouble of trying to embed. They just lie about what the address space is and hope that when somebody looks up an IP address in their security logs and sees that it's AT&T Mobility, they know that this is, they think maybe this is something they can't block and they can't do something with, when in reality, this is actually coming from, I forget where this was, China or somewhere, but this is, this particular case was resolved, but these things pop up regularly. It's another issue of in the realm of BGP security, and we need better vigilance out of the RIRs. The RIR got cut off here in the box on the right here, but that's what that the last word there is saying. And yeah, ROV not going to do anything here. These actually have valid ROAs, so or they have they're valid routes. So this, except for the one in the middle, but the so that's that's not something ROV is going to be able to address. All right, so the last topic here is we'll talk about some of the success here. So measuring success is actually kind of challenging here, and I think this is true for any security mechanism. If you're getting somewhere, and how do you measure how many things did not take place as a result of the security tactic that you've adopted? I would just say that as someone who lives in this data and in this space, and not everybody does. In fact, very few people I think really do. It's aware. We are aware of the fact that there are routing leaks happening with regularity, but the fact that most people don't know this is a sign of success. A lot of these incidents actually get contained to the region or area where they were where the leak took place. It affects those people, unfortunately, but our system of IR filtering, RPI, ROV, peer lock, all kinds of other mechanisms that are out there are preventing these leaks from affecting others, and that is a sign of success. So leaks take place, but we just don't, they're not as disruptive. In fact, I would argue that the last really big disruptive BGP leak might be, I keep saying this at presentations, maybe I'll get, there'll be a new one and I won't be able to say this, make the statement anymore, but back in, this is June 2019, this is the Allegheny Tech Verizon leak that took out Cloudflare. Like, that was the last really big one, and it's not an accident that this is the last one. I think it's a product of all of this work that we've done over the years to try to eliminate or to add additional checks to try to prevent disruption due to the inevitable mistakes and errors that take place. So leaks are still happening. Here's another case. It didn't get a lot of attention, and again, as a storyteller in this space, it's kind of hard to tell the story of something that didn't take place, of successes. But it's important that we understand that this is behind the scenes, transparently to our daily work. The system is actually is protecting us. And so in this case, this is back in September. Brazil, the government of Brazil ordered that Twitter, now known as X, be blocked nationally. And as happens in a lot of countries, the government, the regulator just gives this order out to the ISPs, and they're on their own to try to come up with a way to black hole or block Twitter. And there was a couple of Brazilian ISPs that decided to use BGP. This is we've seen this in other places where they'll announce Twitter's address space to attract the traffic and just black hole it. That's how they'll achieve compliance with the government directive. What these guys did was almost identical to what we saw in Myanmar in 2021 and Russia in 2022. In each of those cases, the government of those places issued a block of social media. Somebody tried to do a BGP hijack to black hole traffic for X, and then the route leaked out, causing disruption outside of those countries. In Myanmar, it was a little more disruptive in South Asia, Southeast Asia. Russia, less so. What had happened between those two incidents was that Twitter adopted RPI, created ROAs for all the routes, and so then it was much easier for networks to automatically just reject the hijack coming out of Russia than it was for the one that came out of Myanmar. Well, we kind of have another example of that in September. One of these providers, this little graphic from BGP to HE.net, if you might recognize the style here. You could probably go look it up now, and it's this little peak that I've highlighted is probably still on this graph on the front page for that AS. But that leak is the entity leaking out all of the Twitter routes. But in the end, it didn't really go very far. It only circulated in Brazil, and it also went through some, peering relationships. But this really caused no disruption outside of Brazil. And again, that's the system working. It did its job. Nobody was involved, and very few people knew. I'm one of them, but there are. We have to kind of know that this stuff is happening. There's other examples, but I'll wrap it up here with just a couple of thoughts here. So, there's a little bit of concern here where we're seeing some signs of slowing RPKI ROV adoption. As I mentioned earlier, this percentage of valid traffic's been stuck at about 74% bits per second since October 2024. I think this was to be expected that we're going to start seeing some plateauing of this adoption, but we want to keep moving forward on this. V6 also seems to be stuck. Maybe V4 is going to hit a similar plateau, and V6 is just ahead of the game again. But how much farther can we go in ROA creation, and is an open question. And then I worry a little about being a victim of our own success, that if we don't have those incidents like the Allegheny Tech leak from June 2019, how do we keep everybody's attention and devoting resources to keep moving this forward? This graphic is, the little highlighted box is the V6 kind of puttering out here since October 2024. And yeah, finally, what's the call to action here? As we always say, so we want you to create ROAs, reject invalids, minimize your AS sets if you've got one. Go check it. What ones are you adopting? Where are you applying? How is this causing problems for you? We need help to support these newer path prevention technologies. Hopefully, maybe we could get out of our reliance on AS sets and IR-based filtering. We have greater adoption of ASPA. This is where an AS will assert in RPKI whether it's transit providers, and then enabling others to look at an AS path and recognize that there's a leak taking place and reject the route. And then additionally, you have RFC 9234, this OTC attribute. Again, a router could automatically receive an announcement, recognize that this is not really meant for them, reject the route, and again, suppress leaked routes from causing any more disruption than necessary. But RPKI ROV and even these others, ASPA, AS sets, these don't solve all the routing security issues. Our success in deploying ROV, I think, is an opening salvo towards addressing this, the ultimate goal of trying to secure against the determined adversary, where you've got an entity that's very knowledgeable and is very good at getting around some of the mechanisms. Like ROV can be defeated if you have a determined adversary. They can just append an AS on the end of a AS path, and it's now valid, and it's not going to do anything. So it's almost trivial to defeat. So it's not really there to address the determined adversary. We need different stuff to defeat that. And there's been a few attacks on cryptocurrency services that are good examples to help us understand what is unresolved, and we've got a lot of work still to do. But let's build off the progress we made with ROV to try to address some of these more difficult scenarios. And with that, I will take any questions.
Thanks, Doug. It's always a pleasure to hear you eloquently spiel for us. We've got a couple of questions coming in. Please keep those coming in. We'll start off with, we've got a comment here about ASET tools, specifically tools like BGP4 lack an exclude option. So you can't easily do something like BGP4Q exclude AS bad asset. So I'll try and spin that if I can. Doug, what are the implications of this limitation for network operators?
Yeah, I'm trying to understand. Yeah, lack of exclude seems. Yeah. Well, yeah, we'd have to think through that of like what. How would you do that? You'd like to. I think the argument is you'd like to use like BGP4Q to use an ASET, and then I just don't know how you would define what would be bad in this case. But maybe there's a way to. I can't think of how you do that, but I think the main issue is that we have AS sets that are excessively recursively nested, so they're just including so much stuff in it. And I think if you knew enough to know that it's got bad stuff in it, you might be taking other measures besides an exclude. I don't know. It's an interesting question. I know some of the developers of BGP4Q, so I might bring that up with them of if there's some way to add something. Maybe that exists and I'm not aware of it, but yeah.
Another webinar for another time.
Yeah, it's a good question.
Okay, we've got a couple of others. Keep them coming in, of course. One here. I mean, Doug is the best person to ask this. What would you recommend, Doug, for someone who is looking to get more into routing, security, internet analysis? Would you recommend certification from, say, Cisco, or just getting more into network engineering experience? What's your kind of take on kind of getting in?
Yeah, for this stuff, you definitely need to yeah, you have to have some exposure to networking. So whether that's like I started off in this space as a baby network engineer, getting a CCNA. It's kind of my introduction to that. Was many years ago, and I thought that was a really good program. I think it's not the only way to do it, but yeah, having some network sysadmin experience is a good base to build off of to be able to get into this type of thing. I guess the other there's a bunch of academic outfits. So we have Georgia Tech's doing a lot of cool stuff in we call this the field of internet measurement. UCSD and CADA has been the leader for decades of this topic. Maybe they kind of founded the whole academic area. So there's a bunch of universities that do a lot of cool stuff. That they publish a lot of important papers that are worth looking into. But as far as how to get into this, I guess becoming a network engineer. I guess routing is I think it's a common topic in the networking space and nano space that maybe network engineering is a kind of a dying breed because everything's kind of in the cloud. You still have to have some of the knowledge, but people are on command at the command line a lot less than they were once were. It's just not a practical way to run a very large network anymore. But yeah, I start with a CCNA if you want to start somewhere.
Awesome. We've got, I think that's a documentation snippet in response to what we were talking about earlier, that the exclude options. We'll probably take that offline if we might. We've got plenty more questions coming in. Wow. As one asks, with the current route filtering practices, nesting of ASets is needed, unfortunately needed rather, when tier 1 ISPs provide IP transit to tier 2 ISPs, who in turn provide transit to tier 3 ISPs. It's impossible, they argue, to keep route filters up to date without some sort of recursion. Doug?
Yeah, I think this comment is pushing back on this idea of like
Sure.
Avoid recursion. I don't know how to maintain how someone would maintain knowledge of what's in the AS set. So I think some recursion is necessary here. I guess I feel like in going through this data, you could find cases where like this. I can't see a justification for the recursion that's taking place in a particular AS set. The comment here is saying that we can't do without it. That they need to, basically, a smaller provider needs to be embedded into a larger provider, into another larger provider, so that guy at the top. So this is from somebody who's at a tier 1 network can inherit. The customer can inherit all of the routes of its within its customer cone. So some of that is necessary. Yeah, I just we go back to the MTS example. who are the components? I'd have to dig into it, or I don't know, Voxility maybe was a bad example, because that's a very unique, a DDoS mitigation provider is going to have all kinds of things in its AS set, and it's hard to argue that anything shouldn't be there. But a Russian mobile operator probably should just have Russian stuff, or maybe their subsidiaries in the Eurasia part of the world. It shouldn't have U.S. Department of Defense prefixes in its AS set, and however that's making its way in there, it's coming through some recursion. But yeah, the point stands that we can't operate without it.
Awesome, thank you. Got a question here. Someone's asking around any recommendations. Have you got any recommendations for BGP monitoring platforms at all?
Well, funny you should ask. No, Kentik is in this business. I think we are one of a number of companies that sell BGP monitoring. If depending on your budget and your time, there's some open source tools that are pretty good. If you so there's a variety of tools out there, and I think from Kentik's perspective, we think the power comes from marrying this up with NetFlow analytics, so we're not just looking at BGP in isolation. We can kind of look at this as it pertains to the operational impact of a network. If you're just looking at BGP, it's hard to know what's the how many packets are getting actually affected by any one thing. But check us out, keep us on your list for evaluation. But there's maybe a dozen solutions out there.
So we talked about certs earlier. Someone else is asking around tools in terms of learning some of the things that we've talked about today. Anything beyond certifications, maybe?
Well, if you can stand to read RFCs published by some of it's dry technical stuff, but if you can invest the time to go through this, it's a good way to learn some of the standards. I think it's kind of a hard path for someone who's new to try to make heads or tails of it. And I don't know, I think it's a bit of a challenge. This stuff is a little esoteric. I had to reach out to some other experts in this space just to confirm some of the facts that I was using for the AS analysis I put out this week. But yeah, tools to learn some of the stuff other than certs. I mean, we've got these forums, so depending on where you are in the world, you've got NANOG in the US and RIPE in Europe. These are our network operator forums, and there's a good way to those are good ways to meet the people who work in this space and to learn, listen to the presentations and learn some of the stuff that was getting discussed. I say that I think a lot of people, myself included, they like talking about it. So sometimes you can reach out to people directly and ask them, and they can try to explain some of the stuff to you. I mean, I would say you do have to have tried a little. You can't just kind of come in with nothing. But if you've given it a good faith effort to learn something on your own, you're still not understanding something. Look at get involved in one of the communities, and I think there's a lot of helpful people in those spaces that would try to set you straight.
So Douglas, something we haven't touched on, this person's asking, is around ASPA development of the kind of new areas, only to customer RFC and BGPsec as well. What's your view on the state development there? They're gaining traction in my view, but I mean, you're the expert rather than me.
Yeah, so BGPsec is not, this is still a conceptual discussion, and it might be something that never goes away. I think there's I'm not sure of the state of affairs and the where we're at with that discussion, but because I think that for a while people have been said this is a dead concept. Basically, you have to cryptographically evaluate every message as it comes in, kind of thing, and this is too much load on the router. I think what kind of brought that back into the conversation was some of the cryptocurrency attacks, like the Stellar Bridge incident that was a hijack of AWS. and I think it was another one that had a similar thing where you had an AS impersonation. And how do you address someone who's successfully impersonating another AS and appending an AS to its AS path to defeat ROV? So you'd like to be able to do this in an automated way. So in the case of, I think, yeah, again, Stellar Bridge, I think it was Aurelion accepted a route from a UK host provider that kind of passed itself off as being from AWS. If there had been some sort of a cryptographic confirmation saying that this route is coming from AWS, if that existed, even if it was only between Aurelion and AWS, then Aurelion would have preferred believing the legitimate one from AWS over somebody who just came in off the street and doesn't and wouldn't fail that or wouldn't pass that test. That is not built. That's not fielded. We do have ASPA operating in a couple places. The deployments, I'd say, kind of minimal. Same with the OTC. Yeah, I've been asked if I could, try to look at how far this stuff has, how much we see in like OTC showing up in our BGP data. I haven't built anything to find that, but I think that thus far it's kind of minimal, and so we're at the early stages of those technologies.
So based on that, I think that was a terrifyingly huge attack from my wider reading. Would you say that kind of routing security incidents are becoming more or less frequent, especially off the back of this concept of BGP-sec coming through?
Yeah, I think this question comes up a lot of how to characterize how things have changed. And again, I've been at this, I guess, 15, maybe going on 16 years now, and so there's the way I try to think of this is that there's a spectrum of complexity, and you've got one end that is, I call it kind of bonehead errors, which are some mistakes happening and people are knocking each other offline due to human error. And then on up to the other end is that determined adversary. Someone who's very sophisticated is going to effectively try to defeat the things that you're fielding. And we've done a lot of good work on that lower end. And that's why I mentioned the comment of this last big disruptive leak being many years ago. I think we're moving the needle up that spectrum in a positive direction. But the other end is one could argue it's almost unaddressed of the attacks against the cryptocurrency services. Some of these, if they were to occur again today, we don't have a way to stop it. So or like the one that happened in South Korea is another cryptocurrency exchange that was attacked. That BGP was one of many components in this kind of supply chain library loading attack. But so I guess the upside is that the bonehead errors are going down, or we're doing better at protecting ourselves from those. But then, we haven't effectively addressed the determined adversary scenario, and we only know a few of them, but there could be more that we don't know, because it'd be very hard to it can be very hard to find these if they're properly if they do a good job of hiding their tracks.
So in relation to that, that's quite a poignant question this person's asking around obstacles for further adoption of security mechanisms like RPKI, RV.
Well, I was on a panel at Apricot, it's like the network operator forum for the Far East a couple of months ago, where the local operators were kind of talking about this. And one of the big issues that they had were just education of some of the networks that they deal with, that they won't, they'll have people trying to buy their transit services and have no route objects created, and they'll say, no, you got to have something so we can filter you. And they're like, we don't know what it is. What are you talking about? Like, all right, so they have to kind of teach these folks some of these basics of this space. So I think education is definitely trying to reach into some of the smaller networks. The big ones that are well resourced, I think they've are somewhere on, they've got a handle on this, but you start to get to smaller networks, and this might be just a couple of people operating something, and they don't have time for it, or they don't have interest, or don't have the knowledge, and so. I mean, there's a lot of obstacles. We also have, I mentioned legacy address space. We've got old equipment that's still in circulation that's not, that can't do RPI evaluation, and that stuff has to get replaced. But that's, those are other obstacles. But I'd say training is the one I haven't really discussed so far.
Thanks, Doug. We've hit time, I'm afraid. So if you have any more questions for the Kentik team and Doug, please reach out directly. Thank you, Doug. It's been it's always a pleasure hearing just how amazing you are in terms of understanding this, because sometimes it goes right over my head. Thank you to the Kentik team. Thank you from Capacity as well. Please keep in touch and make sure to follow us for more webinars like this on Capacity Media as well. Doug, thank you for your time. Thank you for listening as well. All the best.
Thanks.